Welcome back to Java Internals Crashcasts. I'm your host, Sheila, and today we're diving into one of the most powerful concurrent collections in Java, ConcurrentHashMap. We're currently in our Concurrent Collections season, exploring the Maps and Sets chapter. Victor, are you ready to unravel this thread-safe marvel?
Absolutely, Sheila. I'm excited to discuss ConcurrentHashMap. It's a game-changer when it comes to concurrent programming in Java.
Before we jump in, let's make sure our listeners are up to speed. We've already covered the concurrent map interface, which ConcurrentHashMap implements. Now, to get everyone's gears turning, I have a quiz question. In a highly concurrent environment with many threads, approximately how many times faster can a concurrent hashmap be compared to a synchronized hashmap?
Oh, that's an intriguing question, Sheila. It really makes you think about the performance implications of different concurrent strategies. The answer might surprise many of our listeners, as it's not just a small improvement we're talking about here, but let's not give away too much. I'm curious to hear what our audience thinks.
Agreed, Victor. Let's keep our listeners guessing while we explore ConcurrentHashMap. Can you start by giving us a brief overview of what ConcurrentHashMap is and why it was created?
Certainly. ConcurrentHashMap is a thread-safe implementation of the concurrent map interface. It was created to address the limitations of using a synchronized hashmap in concurrent environments. The primary goal was to provide better scalability and performance when multiple threads are accessing the map simultaneously.
That's interesting. So, how does ConcurrentHashMap achieve better performance compared to a synchronized hashmap?
Great question, Sheila. The key to concurrent hashmap's improved performance lies in a technique called lock striping. Instead of using a single lock for the entire map, ConcurrentHashMap divides the internal table into segments, each with its own lock. This allows multiple threads to access different segments concurrently, greatly reducing contention.
Lock striping sounds fascinating. Can you explain it using an analogy to help our listeners visualize it better?
Of course. Think of ConcurrentHashMap as a large apartment building with multiple entryways. Each entryway leads to a specific set of apartments. In a synchronized hashmap, there's only one main door, and everyone has to go through it, creating a bottleneck. But in ConcurrentHashMap, there are multiple entryways, allowing people to enter and exit different parts of the building simultaneously. This reduces congestion and improves overall efficiency.
That's a great analogy, Victor. Now, I've heard that ConcurrentHashMap has some unique characteristics when it comes to null values and consistency. Can you elaborate on that?
Absolutely, Sheila. Unlike regular hashmap, ConcurrentHashMap doesn't allow null keys or values. This design decision helps prevent ambiguity in concurrent operations. As for consistency, ConcurrentHashMap provides what we call weak consistency in its iterators and size method. This means that these operations reflect the state of the map at some point during the execution, but not necessarily its exact current state.
Weak consistency sounds tricky. How does this impact developers using ConcurrentHashMap in their applications?
Well, it's a trade-off between performance and strict consistency. Weak consistency allows for better scalability, but developers need to be aware that the size method, for example, might not always return the exact number of elements if other threads are modifying the map concurrently. In most cases, this isn't a problem, but it's crucial to understand when designing concurrent systems.
I see. Are there any common pitfalls or misunderstandings developers should be aware of when using ConcurrentHashMap?
Definitely. One common mistake is assuming that compound operations on ConcurrentHashMap are atomic. For example, the check-then-act pattern, checking if a key exists and then inserting it if it doesn't, isn't atomic by default. ConcurrentHashMap provides methods like put-if-absent for these scenarios, which perform the operation atomically.
That's a great point, Victor. Can you share some best practices or tips for using ConcurrentHashMap effectively?
Certainly. First, always prefer ConcurrentHashMap over synchronized hashmap in concurrent scenarios. Second, use the atomic compound operations provided by the class, like replace or compute if absent, instead of trying to implement your own. Lastly, be mindful of the weak consistency model when iterating or getting the size of the map.
Those are excellent tips, Victor. Now let's talk about real-world applications. Where might we see concurrent HashMap being used in production systems?
Concurrent HashMap is widely used in caching systems, where multiple threads need to read and write cache entries concurrently. It's also commonly used in producer-consumer scenarios, shared configuration storage, and any situation where you need a high-performance, thread-safe map implementation.
That's really helpful, Victor. As we wrap up, let's reveal the answer to our quiz question. In a highly concurrent environment, approximately how many times faster can a concurrent HashMap be compared to a synchronized HashMap?
The answer might surprise many listeners. In highly concurrent scenarios, concurrent HashMap can be up to 16 times faster than a synchronized HashMap. This significant performance boost is due to its lock striping mechanism and other optimizations.
Wow, that's impressive. To summarize today's episode, concurrent HashMap is a thread-safe, high-performance implementation of concurrent map. It uses lock striping to improve concurrency, doesn't allow null keys or values, and provides weak consistency in some operations. It's crucial to use its atomic methods for compound operations and be aware of its consistency model.
Excellent summary, Sheila. Concurrent HashMap is indeed a powerful tool in the Java Concurrent Collections toolkit, and understanding its intricacies can greatly improve the performance and correctness of concurrent Java applications.
Thank you, Victor, for these insights. In our next episode, we'll be exploring concurrent skip list map, another fascinating concurrent collection. Don't forget to subscribe to Java Internals Crashcasts and leave us a rating if you enjoyed this episode. Until next time, happy coding.